5 meters per second, 11 meter ledge. How far does it go? X. How high above its starting position does it get? And how long is it in the air total? Okay. Okay, so there we go. That's what I'm going to do. That's the first one I'm going to do. Okay, so just like before, we need to know our X and Y components. We need to know our X velocity and our Y velocity. Okay, and both of those are going to be calculated using the initial velocity and our angle. And let's just go ahead and write it down here. Our angle theta is 20 degrees. Okay, I'm trying to draw too small. Our X is going to be 5 times the cosine of 20 degrees, and our Y would be 5 times the sine of 20 degrees. Okay. Now, very first thing, turn this bad boy on and check our mode. Mine was in radians, so let's go ahead and fix it to degrees. Okay, good. So now let's calculate our Vx and Vy. So 5 times the cosine of 20 degrees is 4.70 meters per second. Our y would be 5 sine times the sine of 20 degrees, or 1.71 meters per second. Okay, those are our starting conditions. Okay, pretty straightforward. And now we need to figure out how long it's going to be in the air. Okay, and the way we do that is we are going to figure out how long that the ball rises into the air, and then how long it would take to fall from its position at the very top all the way to the bottom down here. Okay, so we're going to start with Vy and see how long it takes to rise to the top. So delta V equals a delta t, and we remember that it's actually going to slow down to 0 at the very top, so our change in velocity is negative 1.71 meters per second, and that equals our negative 9.8 meters per second squared multiplied by whatever the time is. Okay, and if we divide both sides by negative 9.8, we know that negative 1.71 divided by negative 9.8, and that our ball takes, to get to the top, takes 0.174 seconds. That's how long it takes to rise to the top of this flight up here. But that's not the only bit. Okay, we need to know from there how long it takes to get all the way back down and how high up it went. Okay, so let's see how high up it goes in that first 0.174 seconds. So our initial change in y is 1/2 a delta t squared, or 1/2 negative 9.8 multiplied by 0.174 squared. Okay, so if we square that time we just got, multiply it by 9.8 and divide that by 2, we end up with an additional 0.149 meters. That means from the very beginning, at the very beginning, that the ball actually travels upwards from here to here 0.149 meters. That's how high up it goes. And then from here all the way down, it actually falls 11 plus this 0.149 meters. Okay, so it's actually going to fall down 11.149 meters. Okay, and that's going to help us figure out how long it's actually in the air. So our time to the top is this 0.174 seconds. And now we're going to solve for our time down using our, let's just say delta y2 equals 1/2 a delta t2. And our delta y2 is this 11 right here added to this 0.149. So 11.149 meters equals 1/2 9.8 multiplied by whatever the time is squared. Okay? And we're going to divide both sides by 1/2 9.8. 1.8, and then I'll move this over to move this up here. Okay, so 11 plus that right there divided by 0.5 divided by 9.8. So our time squared up here is equal to 2.275 seconds squared. And if we square root both sides, we end up with a delta t from the very, very top all the way to the bottom of 1.51 seconds. That's how long it would take to fall all the way from the very highest point of its flight all the way back down. So our total time is this plus this. So our total time is that plus 0.174, or 1.68 seconds. That's how long the object is in the air when shot from that very, very tall platform. Okay? And now we want to find out, and we already found out how high up it goes. This right here, how high up it goes from its original starting position. And now we want to know how far it goes outwards from the ledge, okay? And we already figured out that our Vx is 4.7 meters per second, and our delta x equation is Vx multiplied by our change in time, which is 4.70 meters per second multiplied by our total time of 1.68 seconds. And that gives us 4.7 times 1.68, or 7.896 meters from the base of the ledge. There we go. What if the slope is curved? What do you mean by that? What do you mean by that, Quentin? Because that by itself does not mean anything to this section. Let's take a look at this in close-up, and so you can see everything all at once. Everything a little bigger. I don't understand the question. What if the slope is curved?